You might already be familiar with TMForum's fantastic work on defining the API standards for standard telco use cases. As you will notice recently, the Specmatic team has collaborated with TMForum and built out AsyncAPI specifications. If you go to the API directory, you will see quite a few of the APIs now have async tag over here for them. Let's quickly click through and get in, and here you should be able to switch to the asynchronous, and what you will see is the open API, the user guide, the conformance profile, CTK, others are already available. So let's look at what is the thought process and the architecture behind building these. Cool. So the objective of building these asynchronous API is really for encouraging event-driven architecture, especially in telco kind of use cases where you expect very high volumes. Having an event-driven architecture becomes extremely important from a scalability and reliability point of view. So keeping that in mind, TMForum has launched these async APIs. You are already familiar with REST, and TMForum provides a lot of the REST APIs, but now we've also added support for eventing, which allows us to essentially communicate asynchronously. For this, we are leveraging the Async API, which is an open source project and a community that is helping us drive best practices around event-driven architecture. Async API itself is protocol agnostic, and as you can see, it supports several different protocols. At TMForum, we have initially started with Kafka, but soon we'll cover other protocols like WebSockets, MQTT, and so on. Now, when it comes to asynchronous, you might be familiar with two patterns, right? The event, which is essentially notifications that are given, and commands, which could be specific to operation that needs to be done, an instruction or an operation that needs to be performed asynchronously. And you'd be happy to know that we've implemented both events and commands. For events, we are using notifications, and for commands, we've basically taken the REST operations and mapped them to specific commands in asynchronous pattern. How is that implemented? Let's quickly look at the implementation. So what we've done is we've taken the request reply pattern, and what you will see is there is a request topic for commands to be pushed from the requester to the replier, and then the replier can then asynchronously respond back on the reply channel, and the response can be picked up. What we have done is we have taken the standard 5 get, post, put, patch, delete operations from HTTP REST and mapped them to asynchronous commands. And that's basically what you will see going forward, is that each of these commands are essentially mapped to a topic. So here, for example, if you see trouble ticket, we have trouble ticket list, we have a create, we have a retrieve, we have a patch, and we have a delete. So each of these operations then have a command request topic and a command reply topic for the response. I hope this is kind of making sense. Now let's quickly switch gears and look at the architecture of the CTK and the RI. The CTK is the Conformance Toolkit, and RI is the reference implementation for this. So the CTK itself is dockerized, and the developer who is going to run the CTK would need to change the change.me.json, which can be mounted into the CTK. This basically points to where your Kafka broker is running. Then they update the payloads that your reference implementation understands, and again mount those into the Docker. Specmatic itself is being used to power the CTK. So Specmatic will take the payloads and validate them against the Async API specification. And if everything looks good, then the conformance test will get kicked off. The conformance test will basically publish a command onto the command request topic, and this would then get picked up by the consumer. Now, in our reference implementation, we provide all of this, including the Kafka broker, inside a Docker image. We also have a AsyncAPI bridge, which basically picks up the message from the published topic. So the consumer will pick this up and then make a HTTP call to the standard HTTP reference implementation that TMF already provides. And once the response comes back, then the producer on the AsyncAPI bridge would put the message on the command reply topic. And of course, that will get verified by Specmatic. So it will pull the message from the command reply topic and verify against the AsyncAPI specification to make sure that the reply is as per the schema and so forth, right? The client also is capable of publishing notifications on the notification topic, and so the notifications can also be verified by Specmatic now. And when all of this is done for all of the topics, then essentially we generate a report. Now, while all of this is running, you may want to have observability in terms of what is going on. So what we have done is we have built a set of tools as part of the reference implementation for observability. So Kafdrop, for example, to see what's going on Kafka. This is kind of at a high level the implementation of the async API, CTK and RI. Let me quickly switch gears and show you how this is implemented in the code, right? So if you were to download the CTK and RI, what you will see is a folder like this, which basically contains the AsyncAPI specification. It has a Docker compose, which is primarily the main thing. So here we are basically running this thing, the CTK, from a Docker image. We are mounting some volumes. And essentially the examples, these are the payloads that one needs to update if required. And that's pretty much it. So if we do that, then the CTK can run. Now let's quickly look at the reference implementation. The reference implementation is a little bit more interesting because here we are combining a whole bunch of things like Zookeeper, Kafka, Kafdrop, the RI for the HTTP itself, Mongo, and then the AsyncAPI bridge, which we talked about. Now, all of these will get fired up when we run the reference implementation. So let's quickly go here and start our reference implementation. So what this will do is it will pull all the required images, and with that, it should get started. So once this is started, we should be able to quickly look at Kafdrop, for example, to see if Kafka is started correctly or not. I think this is pretty much up. So let's quickly look at this. And sure enough, you will see that we have created 6 topics already. We anticipate that the commands will be posted on these topics. So we have already created these topics. Let's quickly go back here. We also will be able to see the underlying trouble ticket OpenAPI specification itself. This is the HTTP one. So we also know that the underlying HTTP reference implementation is up and running. So this is all good. At this point, pretty much we know all of the RI is up and running. Now quickly, let's go to the CTK and run the CTK and see what happens. So to run the CTK, again, it's a simple Docker command. So let's just quickly run that. Again, Specmatic is going to get fired up here and it's going to start running these tests, and it's going through and posting all these messages quickly. And voila, that's it. Pretty much done. So these tests are now all up and running. Let's quickly look at the report. So this is the AsyncAPI CTK report for trouble ticket. And as you can see, there is a create trouble ticket, a list trouble ticket, retrieve trouble ticket, and delete trouble ticket. Here you would be able to expand and look at what is the payload that was sent, and you would also be able to see what was the payload that was received. So when we create a trouble ticket, in the response, you would see that we would have got a trouble ticket ID, and then going forward, there is a workflow that is maintained. So the same trouble ticket is followed through. So let's look at when we say list trouble ticket, or let's say when we say retrieve trouble ticket, is it the same, ID again? So yeah, as you can see, we are in the request here. We have sent the same request for retrieve, and that would have got back in the response. So this is a little bit of a workflow that we have implemented to make sure that a trouble ticket is created, then it's retrieved, and finally deleted. So I think that is pretty much the architecture of the RI and CTK. And there is a lot more interesting stuff that's going on with the several AsyncAPI implementations. So stay tuned for more.